I'm Eric Schubert, the CEO of Icon LNG. We've been working on bringing natural gas to Guyana for the last 2 years, and as you can see behind me, we've finally arranged our first shipment out of Europe. We will be sourcing the LNG regionally, starting hopefully summer of next year, possibly third quarter of next year, from Trinidad as well as Colombia. The benefits of natural gas are twofold. Number one is mainly the environmental benefit. Burning hydrocarbons such as diesel or HFO, there's a lot of pollutants that get distributed into the atmosphere. Natural gas is a much cleaner fuel. It burns more efficiently and really drops the pollutants that are entered into the environment. The second is cost. Even at today's low diesel prices, our supply of natural gas is still cost competitive, and we're able to lock a price into the customer for 5 years. So the daily fluctuation of diesel prices that affect businesses and consumers will be done away with, because they'll be able to project out for 5 years exactly what their costs will be to provide the power needs for their organizations. And behind me you see an example of how we're going to be distributing it here. These are 40-foot containers. The containers we will be using are our own proprietary 53-foot design. So essentially it's the same, but a little bit longer and a few more axles on it that make it a little bit safer to carry over the roads. A little description of what the container, how it works is, this valve right here is how you load and unload the LNG via a cryogenic hose. You hook the hose up, turn this knob, and once you turn this knob, the LNG is ready to be dispersed once the safety valve is opened. You open the safety valve up and there's a brass clip that connects right here. If there are any accidents with the container, for example a fire starts, this brass clip melts, which quickly releases the safety valve and it shuts off all supply of natural gas coming out of the container. It's a very good safety device to allow you to stop the flow at any time. There's also a cable that goes all the way around the container as well. If you're working around the container and you sense something is wrong or something's not right, you grab this container or cord and pull it, and as you can see, it'll release the valve naturally no matter where you're at around the container and shut off the flow of natural gas. Once the natural gas is flowing, the liquid natural gas is flowing through a cryogenic hose, it goes over to a vaporizer. This is an example of a vaporizer that we brought on site. Each vaporizer will be sized specifically to the customer's needs. And that'll be something that we work on with the customer to see how much diesel they use and how much natural gas we would need to displace that diesel, and then size the equipment accordingly. Thanks.
How you doing? I'm Ron Luquette with Acadiana Energy Systems. I'm here to explain the vaporizer that we use for LNG, converting liquid natural gas back to a vapor. The system that you see behind us is considered a air ambient vaporizer. It's a very simple process where we take from the cylinder that you just looked at through this facility behind us, and it comes out, warms it, it comes out as a vapor. It's a very simple type process. It uses the sun to warm the gas so it does become a vapor. So basically, when it comes out of the system, out of the container, it comes into this port here. It goes through each one of these fins, okay, and frost develops on the outside of them. As Eric may have mentioned, the gas that's inside of the containers that are stored at a negative 260 degrees. So as it's entered, it goes through each of these coils, frost develops, the sun and the temperature warms it, and it exits up from the other side as a natural gas. How's that? Okay. Okay, once the gas leaves the air vaporizer, it comes over to the engine, which is now a vapor. The gas is now a vapor. It enters our system through this port here. It goes through a flow meter, through some regulations, some safety devices, comes up into the engine, and it is introduced into the engine post-turbo, and it's blended with the air. So the natural gas is blended with the air before it enters into the engine. Once it enters into the engine, we start reducing the amount of diesel that is supplied to the engine. The load, as the load on the engine goes up, there's more gas introduced into the engine. Up to 70% natural gas is added, so only 30% is utilized within the engine, and that is the only reason you have 30% is to create the spark within the engine to ignite the gas, which makes it run. The engine itself does not lose any power or anything of that nature. This is the brains behind it. It's a modern, high-tech control system where it monitors all the different devices within the engine itself. So it's a very simple technology. It's been around since the 60s. We're just bringing it back to use now that LNG is available within Guyana.
Hi, my name is John Zahir. I'm from Continental Controls Corporation based in California, San Diego, in the United States. We are a fuel control valve manufacturers for recip and turbine engines since the 1960s. We have been great, and we're almost the so-called the godfathers when it comes to control systems. A few years ago, in 2007 or 8, we decided to look into a diesel engines and see what we can do by implementing or injecting natural gas into a diesel and provide savings for the end users. So we came up with a technology, what we call a gas substitution interface system. What it really does is it injects natural gas into the intake manifold. The system is composed of several components. The primary one is a gas flow meter that measures the gas volume. We have what we call a gas manifold. It has a redundant safety shutoff valves with a reduced pressure regulator that regulates 100 psi or 150 psi supply pressure that's coming in from the customer input to a 2 psi inputs. So if you can come here, for instance, this is an electronic proportional regulator. The way this works is we get a fuel signal from our computer, the gas substitution interface. It sends a signal into the valve by telling it how much gas you need in order to reduce the diesel. The way this system is set up, we are constantly communicating with the engine electronic units, or the ECU, or we're continuously monitoring that. So let's say at 100% load, this engine will be running 100 liter per hour at one constant load. Now the way we set up our system is we tell it that, okay, we want to save about 70% of that diesel. We want to burn 70% less diesel, meaning. So we put a set point of 30 liter per hour into our system. Our system sends electronic signal to the electronic pressure regulator until it will inject gas until that diesel fuel flow reading from the engine ECU drops to that 30 liter per hour. Once it drops to 30 liter per hour, then you know you have your maximum substitution of 70%, and it will maintain it there. In the case if you lose natural gas, the engine will go back to 100% diesel. You can just press the button, for instance, if you, in the case of some fault or anything, you can press the button, it will shut down the gas, and the engine will not even know that, oh, I lost the gas, I'm going to shut down. The engine will continuously go ahead and perform. So this conversion does not affect the performance of the engine. It still maintains the original manufacturer performance specs. We have safety features embedded within the system. We're looking at a vibration sensor in here, for instance. If there's any vibration that's beyond the customer or the engine manufacturer specifications, it will send signal to our computer telling it to shut down the gas. Then the technician will come out and look at and analyze the whole system to see why we had such a fault code. And then it also looks at the exhaust temperature. That's another safety thing, is if the exhaust temperature goes up beyond the user limit, the gas will be shut off too. Again, it's the technology has been around. The dual fuel technology has been around in the world since the 70s. So it's nothing new. How well you do it, who does it well, that's the most important thing. Since our company has been around since the 1960s, we're good on controlling and providing a best and accurate air-fuel ratio. We thought this was a best way of approaching with a great solution on this, and came up with this technology. We had hundreds of these engines, from Caterpillars to Cummins to Perkins to Detroit Diesel, and Volvo as well. We have converted them, not fully conversion, but dual fuel them or bi-fuel the engines.